Hey, so today we're going to dive into a new topic, and that is the mole. Of course, I'm not talking about the animal, that little furry critter that digs around. I'm talking about the number that allows us to count atoms in chemistry. Okay, so there are other great YouTube videos about this, just so you know. Tyler DeWitt on YouTube gives great coverage of this. Brain Pop, if you have a subscription, is a great way to introduce yourself to it. In this video, I'm going to take just a slightly deeper dive into how to use the mole and what it is, and provide some notes for the students of my chemistry class. So, as we've already learned, okay, a mole, it's a number. Definition. It's a number. Typically we use this number to count atoms, but it's just like a dozen. A dozen is 12, a ream of paper is 500. You know, we have all these named numbers in English that make it very convenient to count certain things. A dozen is really convenient for baking, and eggs, a dozen eggs. A ream, 500, it's a really convenient word for talking about counting paper. And a mole is a really convenient thing for us to count atoms. Okay, it's a number used for counting atoms. That number is 6022. And then there's some more digits, but I don't exactly remember what they are. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This number is a mole. And you know what? It was kind of a pain in the butt to write it, wasn't it? I think this works out to like 602 hexillion or hextillion. Or, if you don't want to write all this all the time, and I sure don't, then we use scientific notation. And in scientific notation, you just write 6.02 times 10 to the 23rd, which is a fancy way of saying if I started at this decimal place and I moved 23 spaces to the right, that would give me this big giant number, 602 hextillion. Okay, so this number is a mole. You're going to want to remember that. I'll tell you in a minute why this number is so special, but suffice it to say, this is a very convenient number for chemists for counting atoms, and we'll see why in a minute. Now, the guy who is credited with this number, his name was Amedeo Avogadro. Sounds kind of like avocado. And so we call this number Avogadro's number. Now, my lucky number is 8. So just so you know, Stockinger's number is 8, and it is known worldwide as Stockinger's number because that's how famous I am. Now, back to Avogadro's number. Why is it so sweet? Okay, why is this so important? Why 6.02 times 10 to the 23rd? Well, Avogadro, in his infinite genius, him and some other scientists figured out that this is exactly the number of atoms you need so that the masses on the periodic table are in grams. Okay, so Avogadro's number, more specifically, this is the number of atoms you need so that you have exactly 12.01 grams of carbon. And you can see the mass on carbon is 12.01. But normally when we think about masses on the periodic table, that's the mass of an atom, right? One atom of carbon has a mass of 12 amus. Well, a mass of 602 hextillion atoms, Avogadro's number of atoms of carbon, that's 12.11 or 01 grams. That is convenient. Basically, that means we can count atoms. Okay, so Avogadro's number is the number of atoms so that masses on the periodic table are in grams. This is a big deal. Okay, This fact allows me to do things that you might think are superhuman. For example, here's a container with some water in it. I happen to know exactly how many molecules of water there are in this container. This container has Avogadro's number of molecules. This has 602 hexillion molecules of water in it. How do I know that? Here's sodium chloride. Okay. This, same deal, has the same number of particles of sodium chloride as this has water. This is Avogadro's number of formula units of sodium chloride. Okay. It's a mole of sodium chloride. Here's another molecule. This is sucrose, C12H22O11. Okay. This, believe it or not, I couldn't fit it all in a small container, but this is the same number of particles as this. This is 1 mole, 602 hexillion molecules of sucrose. And this is 1 mole, 602 hexillion. How could that be? This is obviously more, isn't it? Well, if you think about it, think back to dozens, right? A mole is like a dozen. If I had a dozen toy cars, little tiny toy cars, don't you think that a dozen toy cars would be a lot smaller than a dozen real cars? You see, a dozen is for counting anything, no matter how big or small it is. So the fact that this sucrose is so much bigger than this sodium chloride tells me that these sucrose molecules must be a lot bigger. These are like the real cars, and these molecules are like the toy cars. But it's the same number of particles. Okay. Same thing with the mass. This is a lot heavier. This is a lot lighter. And that's because a molecule of sucrose is a lot heavier than a molecule of sodium chloride. So if I had a dozen cars, that would be heavier than a dozen toy cars. A mole of sucrose molecules is heavier than a mole of sodium chloride. Okay. How do I know these are a mole? Well, it's what I just told you. It's the mass thing. This is H2O. Look at the periodic table. A mole of oxygen is 16 grams plus 2 H's. Each H is 1. So all I had to do was put this on my kitchen scale and fill it with water until it was 18 grams. Oxygen is 16 plus 2 hydrogens is 18. 18 grams is 1 mole, 602 hextillion molecules of water. Okay, I'm probably saying that wrong, by the way. I don't know if it's hexillion or sextillion or I don't know. I've heard it said so many different ways. But isn't that cool? That with a kitchen scale, I can count how many atoms there are and how many molecules there are in a container. That is fantastic genius. Avogadro's number is power, I tell you. Okay. Now, when you have the mass of a mole of something, that has its own name. That's called the molar mass. That's the mass of 1 mole of anything. Okay. Conveniently, because the mole, Avogadro's number, is designed for the periodic table, the molar mass is just the periodic table mass of anything. Okay? So when you're looking for the molar mass of anything, all you got to do is look at the periodic table and add them up. So example 1, sulfur. I can look over here in the corner, and it's 32.07 grams per mole. Okay. Yeah, I know that if I have 32.07 grams of sulfur, that's 1 mole of sulfur. And we could also do my water that I just did. If it's a molecule with a formula like this, you just add them up. That's 2 hydrogens plus 1 oxygen. Okay. So HO, hydrogen is 1.01. Oxygen is 16.00. I just got those from the periodic table. I've got 2 of these, 1 of these. So I multiply it out, add it up, and we have 18.02 grams per mole of water. Okay, that's the molar mass of water. And that's pretty much it, right? The mole is a very special number that gives us the power to count atoms, and it helps us do calculations later on. Like, we'll be able to run a chemical reaction, and we'll be able to know ahead of time, if I put 10 grams of A with 10 grams of B, how many grams of my product are we going to get out of the reaction? You can actually predict that. And in the real world, that's a really important thing, right? If I'm a factory where they make ethanol, which is an additive in gasoline, for example, I need to know how much ethanol my factory is going to produce, and moles allow me to do that sort of calculation. So, enjoy working with these. Lots of good memes about this, by the way, on the internet. I encourage you to check out the mole memes. Have a good day. See ya.